MOE models and local inference trade-offs. The ongoing debate over mixture of experts, MOE, compared to dense large language models, LMs, for local hosting on consumer-grade hardware is attracting renewed attention as both software and hardware advance. Dense models, where every token passes through the entire parameter set, tightly couple inference capacity to available VRAM. The upshot, on GPUs under 24 GB VRAM, a common ceiling for top consumer cards, the largest dense model you can run efficiently caps at about 30 beat parameters, restricting those aiming for truly frontier performance at home or on small business setups. MOE models, in contrast, activate only a subset of experts per token, reducing per-step compute and VRAM load. This architecture dominates in large data center deployments, where throughput and concurrency are vital. The skepticism for home users, however, is whether MOE is worth it at small scale. After all, total model size balloons, with much of it dormant at inference, and optimal MOE routing and fine-tuning are still less mature than dense counterparts. Emerging consensus now suggests the MOE trade-off isn't bad, if and only if you exploit hybrid CPU-GPU workflows. MOE lets you offload dormant experts to system RAM and dispatch them via underutilized CPUs, making full use of otherwise idle hardware resources. The strongest local case gains are seen on machines with ample RAM, 64 GB plus, where models like GLM 4.5 or Qwen 3 Next 80B can deliver high-quality outputs at 4 to 15 tokens press. Performance-dense models can't approximate when pressed against VRAM limits. Apple Silicon users with unified memory architectures represent a sweet spot. Unified RAM is vastly cheaper and more abundant than GDDR HBM VRAM, allowing MOE models, especially quantized MLX or VLM flavors, to shine. Even sub-8 GB GPUs can handle long context operations with the right offloading policy. But for those with high-end VRAM cards, 48 GB plus, dense models up to 70B remain competitive, provided you can fit your workload without offloading. There's a catch. MOE fine-tuning remains more complex and less mature than dense, and optimal routing offloading setups require some technical savvy. Yet advances in MOE routing, shared experts, and token assignment, plus tools like LM Studio and VLLM, are closing the gap quickly and extending accessibility. Bottom line, for power users with flexible hardware strategies and who configure their inference stacks thoughtfully, MOE models now offer the most efficient path to high-scale local LLM performance. Vision and multimodal AI on the move. Multimodal models, those handling text, image, or audio, are multiplying, and their performance is starting to rival earlier single-task systems. Apple's FastVLM7B presents a hybrid vision encoder, FastVHD, that outputs dramatically fewer tokens and slashes image processing time. Compared against Lava 1 Vision, FastVLM.5B is up to 85 times faster in time to first token, TTFT, with the largest FastVLM7B variant outscoring Cambrian 1.8B on key vision language benchmarks, all while sticking to a leaner memory footprint. Tencent's Hunyuan MT7B and Chimera models are raising the bar for open-source machine translation, not just supporting 33 languages, but also delivering SOTA results in the WMT25 competition, outperforming in 30 of 31 categories. The Chimera 7B ensemble model refines translations by aggregating outputs, workflows previously reserved for much larger closed models. Audio AI is keeping pace. Qwen 3 Omni 30B A3B Captioner brings automatic, low hallucination captions for complex soundscapes, effectively parsing both nuanced speech and multi-source ambient scenes for content description, emotions, and even implied meaning. The model is strictly audio in, text out, handling multilingual and cross-modal understanding, and is optimized for both Hugging Face transformers and VLLM, with enhanced performance from Flash Attention 2. On the TTS front, VoxCPM uses a tokenizer-free approach and context-aware design to achieve expressive speech generation and zero-shot voice cloning, all on consumer-grade GPUs. Its deep integration with Comfy UI allows fast, direct conversion of text to realistic, emotion-preserving speech, with few dependencies and plenty of open-source extensibility. And for local deployments, especially on constrained edge devices, frameworks like Nexa SDK are rapidly lowering the barrier to multimodal AI. The Nexa stack can now run text, vision, audio, and speech models on phones, tablets, and PCs, supporting diverse backends, Intel NPU, Apple A&E MLX, Qualcomm Hexagon, etc., and boasts day zero support for Snapdragon X2 Elite and MLX GGUF standards. Parakeet v3 brings offline private speech recognition to iPhones and Macs, further eroding the cloud's monopoly on core AI capabilities. Local AI agents and model orchestration. Local agentic AI systems, where multiple specialized models collaborate, are moving from heady research to practical, user-friendly reality. Observer, a free and open-source multi-agent builder, takes this to the next level by letting users automatically create and orchestrate agents using Llama-hosted models. Observer's interface supports system prompt iteration and easy troubleshooting. A click can fix misbehaving or hallucinating agents, enabling workflows like screen monitoring, real-time problem extraction and solving, or guided processes, e.g. automated Google account creation, all running locally. This orchestrated multi-agent approach is blurring the lines between bespoke automation and general-purpose AI assistance. Within this landscape, Apple and Anthropic's continuing debate over whether LLMs reason or merely pattern match has sharpened. Apple's skepticism has been answered, in part, by studies from Anthropic. Models appear to make forward plans, e.g. finding rhymes before crafting sentences, even if their operation is ultimately, mathematically, token sequence prediction. The community reaction is pragmatic. Utility trumps philosophical rigor. LLMs routinely achieve feats previously thought out of reach. 50 temps productivity gains for programmers aren't uncommon. The core lesson, even if it's ultimately faking reasoning, the effect can be indistinguishable from the real thing for a growing range of use cases. Meanwhile, the research community keeps pressing ahead. Long-Ada introduces the first extensible, training-free mechanism to endow diffusion-based LLMs with long context, exploiting rotary position embedding, ROPE, scaling laws. Where autoregressive LLMs collapse on long context retrieval tasks, diffusion LLMs, a relatively new architecture borrowing from diffusion models in Vision, can both maintain low perplexity at ultra-long contexts and uniquely excel at recent context recall. Long-Lade's empirical proof. Context extension techniques aren't just for the AR paradigm anymore. Agentic coding and the Codex Claude shift. The arms race among AI-powered coding assistants just tipped in favor of OpenAI's Codex. Despite being a bit slower and arguably more friction-prone, particularly with its code execution approval system, Codex is consistently rated as producing vastly higher quality, more reliable, and more production-ready code than even heavyweights like Anthropic's Claude or OpenAI's ChatGPT-5. Where Codex shines, especially through its command line interface, is on hard bugs, complex legacy codebases, and multi-file projects. Users report minimal AI slop, the messy output others leave behind, loyalty shifts from Claude, and a newfound ability to largely set and forget their complex program builds. Still, friction remains. Approvals on batch operations can be a drag, though auto-approval exists for those willing to accept the risks. Cost can become a concern for coding-intensive users. $10 a day or more for high-volume API tasks isn't rare, and workflow convenience sometimes breaks down on Windows systems unless mitigated with workarounds, like using WSL MSYS2. The common workaround is a hybrid approach. Batch serious work in Codex, supplement with Claude or ChatGPT for lighter tasks, to stretch budgets and bypass daily, weekly rate limits. The move toward agentic programming, where the AI plans, executes, and reasons about next steps, not just autocompletes, seems irreversible. Codex's ability to handle everything from architecture draft, code generation, debugging, to even changelogs and icon creation, all in a tightly looped cycle, is shifting best practices and reshaping developer productivity expectations across industries. Neural efficiency, quantization, and speculation. One of the deepest bottlenecks for AI models, especially large ones, remains memory. The emergence of bit-is-all-we-need models demonstrates a radical new direction. Binary normalized neural networks using only 0 and 1 as parameter values. Their tests show next token prediction and image classification accuracy nearly equivalent to 32-bit models, all at 1/3 of the memory footprint. These new binary normalized layers, fully connected, attention, convolutional, etc., break the prevailing trade-off between efficiency and quality, and are implementable with 1-bit arrays on standard hardware. poised to bring foundation models to mobile and edge settings previously unthinkable without custom silicon. Speculative decoding is another optimization, making local AI agents faster and more responsive. The Qwen 3.8b agent, with agentic tool use and multi-step reasoning built in, runs on recent Intel Core Ultra chips using a small, depth-pruned draft model to propose token batches, which the larger target model then verifies. This setup delivered a 1.4x speedup, critical for agentic AI where long thinking aloud traces and multi-step reasoning otherwise risk interface sluggishness. Complementing this, the anatomy of high-performance matrix multiplication, MATMUL, kernels on NVIDIA GPUs remains a foundational technical lever for further speed gains. Deep dives into kernel optimizations demonstrate just how much untapped throughput remains for open-source inference stacks, an essential resource as models grow and on-device deployment outpaces Moore's law. Privacy, security, and robustness in AI. With the proliferation of generative models, synthetic tabular data is rapidly becoming a mainstay for sharing data in sensitive domains like healthcare or finance. The downside, membership inference attacks, MIAs, are still remarkably effective, even against state-of-the-art diffusion models. EPT, a black box attack, shows that by training attribute prediction models on purely synthetic outputs, one can reliably detect the inclusion of real records in a model's training set, achieving up to 22% TPR at 10% FPR on competitive benchmarks. This exposes the privacy utility trade-off that synthetic data providers can no longer hand-wave away, with the call for stronger regularization and possibly even differentially private training in production. On the system security front, Graphene OS continues to blaze a trail for privacy-hardened Google-free Android. The latest release, 22509-2700, brings nuanced RCS integration for Google Messages without surrendering the strictest permission requirements, hardware-level battery risk mitigation for Pixel 6a, multi-channel security updates with opt-in previews of Android security bulletins often before AOSP OEMs, and upgrades to the sandboxed Google Play compatibility layer, all under a rigorous multi-stage OTAs and downgrade-proof update regime. The project remains explicit in its critique of slow-moving OEM patch embargoes, pushing for a 7-day security embargo model, and engineering to leave stock Android in the dust for those prioritizing privacy, longevity, and transparency. New agentic research tools like Goalie MCP are codifying a new baseline for reliable knowledge work. Built on the Perplexity Search SDK, Goalie breaks down research tasks via goal-oriented planning, ACE search, ties every model claim to a source citation, flags conflicting information, and even includes cryptographic signature frameworks for provenance verification. As misinformation risks climb with every model release, frameworks like Goalie point toward a future of AI outputs audited and trusted with cryptographic certainty. Robotics, tiny-scale models, and automation frameworks. Tiny-scale AI models and flexible adapters are expanding the reach of robotic manipulation and embedded vision language action (VLA) tasks. The VLA adapter from OpenHelix team exemplifies this by letting researchers fine-tune prismatic VLMs, e.g. Qwen 2.50.5b backbone, for robotics workflows on anything from 10 GB VRAM GPUs to 80 GB data center cards. The Pro version slashes memory requirements further while keeping accuracy constant, supporting rapid experimentation and field deployment even in shared and constrained research environments. Libero and Calvin integration ensures applicability across major robotics datasets. Ongoing updates promise seamless pairing with ARMs like Franca and UR5 and expanding support for policy networks and manipulation environments. Automation at the image-video boundary also continues to evolve. Comfy UI OneAnimate preprocess provides helper nodes for the OneAnimate 2.2 workflow, handling preprocessing tasks such as face cropping and keypoint extraction for segmentation, a critical tool for robust and efficient video AI pipelines. On the retro hardware front, efforts to preserve, repair, and even enhance classic gear still resonate. The revival of an original 8-bit Sound Blaster 2.0 ISA sound card by replacing the missing Atmel MCU with modern equivalents and hand-soldered pads showcases the interplay between nostalgia, repair expertise, and low-level hardware knowledge of FM DAC mixing ratios, a reminder that the frontiers of technology sometimes require looking both forward and back at what's possible. Policy, legal, and platform updates. AI deployment is no longer just a technical puzzle. It's entering the world of policy, legal risk, and consumer protection. Amazon's $2.5 fine for using deceptive dark patterns to enroll users in Prime underscores the regulatory scrutiny hovering over big tech. While such enforcement is not AI-specific, it foreshadows likely future reckonings for model developers leveraging aggressive onboarding or insufficiently transparent capabilities. Meanwhile, projects like MCP Router v5.5 are giving users more control over local secure environments based on the Model Context Protocol, MCP, with features like offline first operation, workspace switching, and broad MCP ecosystem compatibility. These platforms, not unlike the traditional TCP/IP stack, are becoming essential glue for those running decentralized, agentic, and privacy-sensitive AI deployments on premises. As local, multimodal, and agentic AI formats come of age, and as security, transparency, and privacy become paramount, the technology narrative is being shaped as much by community-driven tools and open research as by major platform releases or public policy battles. Trust, through interpretability, cryptographic assurance, and policy compliance, is fast becoming the next foundational innovation.